Okay, so we're going to finish the lesson 2.5 notes. Remember, these were properties. We had some examples here. We did a proof. All of this is deductive reasoning, okay? We have two more proofs that we're going to discuss. So on the second page at the bottom here. So remember that the parts to a proof are the given information, what you're trying to prove, which typically is written as prove whatever. This is kind of asked as a question. What is the value of x? We know that will be done when we show that x is equal to 75. That's really what we're proving. You'll have a statements column. You'll have a reasons column. And then with geometry proofs, if it's not an algebra proof where you're solving an equation, if it's a geometry proof, then there's typically a diagram also. Notice that there is given information over here on the diagram as well. Sometimes they will not write all of it in the given here. Sometimes it's shown on the picture. So that x and 2x minus 75 is not shown in the given. Okay, so obviously our first step is given. Step 2, angle RAB is congruent to, what should that other side say? Angle RAB is congruent to angle BAN. What's the reason for that? How do we know that these two angles should be congruent?
It says that
okay, so what do I write as the reason? It's because it's a bisector, so what do I write? Who can help her? It's Brooke's birthday, so help her out. Imagine. Angle bisector what? Partially at the end, definition. Definition. It's the meaning of the word. Like, you know what an angle bisector is, so when you say, oh, it's because it's an angle bisector, that's because you know the definition of angle bisector. Okay, from that step to the next step. I think I mentioned this up here, but we obviously didn't have a lot of time to talk about that. Anytime that you go between congruence and equality, no matter which way you're going, because it's a biconditional, that's going to be the definition of congruence. So if they're segments, it's definition of congruent segments. If they're angles, it's definition of congruent angles. Okay, so that's what's going on here, is we are going from these angles are congruent to saying that their measures are equal. So that is the definition of congruent angles. So you can say just definition of congruence. It's okay if you just say that. It's okay if you write out the word congruence or congruency. Okay, you'll usually see me write that, definition of congruent or definition of congruent angles. Okay, x is equal to, what are they doing in this next step? Where did that x come from? Where did the x come from? Not one. Yeah, they're substituting, right? So what goes on in the other side here? 2x minus 75. So that is a substitution. And again, we're looking at the diagram over there and seeing that those expressions were given on the diagram. Okay, what are they doing from that step to the next step? How did they get 0 on the left side? Okay, so if you want to write this extra step here, just going to help you think through it. It'll be 0 equals x minus 75. Okay, subtract x on both sides. And then Frankie, oh, so that's subtraction. Also, let me remind you that when you abbreviate, you're never going to use SUB because we won't know if you're saying substitution or subtraction. So make sure you have at least 4 letters. Probably 5 is better. You can write the word subtract, okay, but it's property of equality because when you're doing on both sides of an equation, the operation ones are always something you're doing on both sides. So you subtracted x on both sides, so it's subtraction property of equality. To get to the last step, what happens? How did that become 75 equals something? What are they doing now? Johnson. Yeah, they just added 75. Now you're saying from one side to the other, and I know what you mean, but technically we're adding it to both sides, right? Like we'll usually say, like, we're going to move the 75 over, and that means add it on both sides of the equation. So 75 is equal to x, and that's addition, property of equality. Okay. The next problem. So it says write a 2-column proof. We've got a picture here. So again, our parts are the given, the proof, the statements, the reasons, and then this one has a diagram because it's a geometry proof. Again, when you're just doing a solve the equation times, there won't be a diagram, but we do have a diagram over there. They have already marked the congruent segments on it. If it's not marked, you should do that. Mark the given stuff on the picture. Okay, remember this is deductive reasoning. We're going from given information and then applying logic to go from that to what we're trying to establish. All right, so step 1, given. Okay, what is it from step 1 to step 2? So from here to here, that's what you write there. What is that from step 1 to step 2? Okay. Yes. See how they look almost the same? Definition of congruence is kind of subtle, and it almost looks like it's the same thing, but that's because you know what that symbol means, right? You know that congruence means they have the same length. So whenever you're basically just swapping out congruence and equality, that's definition of congruence. You can write it like that. You can write congruent segments. Or again, the word congruence or congruency. Okay, this one is different than the other 2 proofs that we did because this one we have our given and we just use that to get step 2. Step 3 is not coming from step 2. What is the reason for step 3? Not good? That is reflexive. Property of what? Property of equality. Reflexive, remember, is the one that says it's the same exact thing on both sides. You have physically written the same thing on both sides of the equation. Now, 3 did not come from 2. That means we still have step 2 to deal with. And actually 4 is coming from both 2 and 3. What is happening in number 4? Two and 3 are being combined together to give us step 4. I've already talked to Henry and Sam, and Anatye and Brooke and Madeline, and most of the people on this side of the room. Let's see. Caroline, what do you think that is? Yeah, you're just adding on both sides, right? You're literally saying, I had AB, I still have AB. I had CD, I still have CD. But what I did is I added BC on both sides. Okay, so you added BC on both sides of that equation in number 2. So now we've used 2 and 3 to get 4, so we don't have to worry about those anymore. That is just addition, property of equality. And again, the operation ones are something you're doing on both sides of the equation. You added on both sides of the equation the segment BC's length. Now, let me go back up here for a second. What we're proving is that if these lengths are the same, then this length is the same as that length. Now, that hopefully makes sense to you because BC is the same segment in both of those, like part of both of those. So when you add BC, of course, to the same amount, of course, those should be congruent. Okay, now for this next part here, it's saying AB plus BC equals BC plus CD is somehow turning into AC equals BD. AB plus BC and BC plus CD. Why is that AC? And why is that BD? What is that? Somebody be brave and guess. AB plus BC is AC. BC plus CD is BD. Okay. Okay, it's not transitive, but we're going to talk about it in a minute why it looks like it might be transitive, but why it's not. Allison, is that what you thought too? Okay. It's not transitive, but I know why you think it looks like transitive. What is it when you look at a diagram? Let me make a simple diagram here. What is it when you look at a diagram and you say, segment there, that the parts add up to the whole? This plus this is that. That is segment addition postulate, right? Okay, so what they're doing is they're saying, hey, I know what AB plus BC is equal to. It's equal to AC. So they're literally just saying, let's replace this, like put that and replace it with AC, and take this and replace it with BD because of the segment addition postulate. You're kind of doing substitution at the same time, but segment addition postulate is kind of the more powerful of the reasons. So you could say segment addition postulate and substitution, but if you're going to put only one thing, you'd say segment addition. Okay, and then so we use step 4 to get step 5, and then we're using 5 to get 6. And the reason for number 6, what's the reason for number 6? We're going from equality to congruence. Up here, we went from congruence to equality. Here, we're going from equality to congruence. What is that? Okay, let's look up here. And look at this. But they're not angles, they're what? Segments. So whether you go from equality to congruence or congruence to equality, that's the meaning of the word congruent, right? Congruent means they have the same length. So definition of congruent segments. So kind of notice what happened was they started out with the congruence and they moved it into equality because addition is only a property of equality. When you're going to be making equations and doing things like adding and substituting, you have to have equations, not congruences. You can't add with congruences. So that's why they put it into an equation form and then they put it back into congruence because that's what it said to prove. Like I could have just made the proof statement the equality here, and then we could have stopped right there, but the proof statement was proving that they're congruent. Okay, let me go back to why this looks like it's transitive. So segment addition postulate is often confused for transitive because you're seeing that B there is the same, and you're trying to cancel that out and relate A to C. And I get why you think that looks like transitive. However, why is B the same in both of those expressions? Why is B showing up in both of those expressions? Why is there a B here and a B there? Caroline. It's not necessarily the midpoint, but it is a point on the segment, right? It's the shared endpoint. So the reason that B is there is because, look, B is the endpoint of both segment A, B, and segment B, C. Okay, why is C here? Well, C is on the segment, so it's the shared endpoint of segment BC and segment CD. Okay, so the reason that it's not transitive is because transitive has to have two equations. This is what transitive looks like. Oh, I missed this so much. They waited until after school to drill the other day, and that was so nice, but now they're back. Transitive has to look like this. So transitive has to give you two equations, like if xy equals mn and mn equals pq, then xy equals pq. Okay, transitive is going to give you two equations, and it's going to be matching a whole side of an equation to a whole side of the other equation. Then you can take that out and relate the first and the third, okay? This is just one equation. You're saying that when you add A, B, and BC, you get AC. It's just one equation. Okay, so that is segment addition postulate, and also segment addition applies in a diagram. Okay, that one is segment addition versus transitive up above. Okay, any questions on the proofs that we talked through today? I'm going to keep doing some more of this, and then we're going to go over homework. Okay, I want to discuss with you the difference between substitution and transitive. Here is an example of substitution only. That's not transitive. Substitution property that is not transitive. If x plus 3m equals 8 and 3m equals 20, then what would your conclusion be by substitution? Right, what would it be the conclusion if you did substitution there? What would be the conclusion if you did substitution there? You combine these two together using substitution. What would be your conclusion? Is x equal to 3m? Plug one of them into the other. Three m is 20. Where can you put that? Yes, good. Okay, since x is 20, we can go ahead and just plug that, or I'm sorry, since 3m is 20, just plug that in. So it'd say x plus 20 equals 8. Okay, that is substitution. Now, why is this not transitive? Well, remember transitive is supposed to be, I'm going to do the thing 1, thing 2, thing 3 again. Transitive is supposed to go, here's thing 1, and thing 1 is equal to thing 2. Now, is this thing 2 or is this thing 3? Or, sorry, is that thing 1, thing 2, or something new? That's what I meant. Is this thing 1, thing 2, or something new? Something new. Okay, is that thing 1, thing 2, or thing 3, or something new? Is this thing 1, thing 2, thing 3, or something new? All right, let's back up. Here's thing 1, here's thing 2. This is thing 3 because it's not the same as the other ones. Is this thing 1, thing 2, thing 3, or thing 4? Is that a repeat or is it something new? something new. So there's 4 things there. That can't be transitive, because transitive has to repeat an entire side of one equation as an entire side of the other equation. Okay, for transitive, you have to be able to wipe out an entire side. So for transitive, you need only 3 things. So typically substitution that's not transitive will look kind of like this, where you're just replacing this one term. Okay, we're not wiping out a whole side of the equation, we're just substituting into an equation by replacing one term. Okay, that one is substitution but not transitive. Now let's look at one that is transitive, property of equality. If MQ equals ST plus 8 and MQ equals 37, then what is the conclusion? Frankie, what would be the conclusion by transitive? Okay, I don't want you to do any simplifying. I just want you to plug it in. Here, would it make you happier? It would make me happier. Here, let's do this. Let's say this is PR. Okay. PR equals ST plus 8. Now, why is that transitive? I'm going to explain why that's transitive. Okay, if you say thing 1 equals thing 2, is that thing 1 or thing 2 or thing 3? If this is thing 1 and this is thing 2, what's this? I'm just clarifying something that you said. So thing 1, thing 2, what is MQ? Is that thing 1, thing 2, or something new? Is this the same as that, or neither of them? It's the same thing, right? Yeah. So because we have this whole side matching with this whole side, we can take those out and relate the other things to each other. Okay, so transitive, we're going to wipe out an entire side of an equation, of the 2 equations, right? And then mush them together. Now, the question is that also considered substitution? Is there a way to consider this as substitution also? Is it possible to call that substitution? Anate is saying yes. Tell me how. Yeah, so you can also call it substitution because you can say, all right, let's take out MQ right here and let's put PR in its place because PR is equal to MQ. And when you do that, you're going to end up with PR over here instead. So that one could actually be considered either transitive or substitution. Okay, sometimes transitive is also substitution. But substitution is more specific, so sometimes it's just substitution. So the first one is just substitution. Okay, this one is either. I think transitive is a better answer because MQ is a whole side, and then we can wipe it out and relate the other ones. But it's not wrong to say substitution. That one would also be substitution. Okay, how about this? If measure of angle A plus measure of angle X equals the measure of angle T, oh wait, I don't want to say that, not plus. If the measure of angle A equals the measure of angle X, and the measure of angle X, oh my gosh, let me start this over again. I'll have to start it for a minute. Okay, if angle A is congruent to angle X, that's what I mean to say, and angle X is congruent to angle T, then, Allison, what would be the conclusion? Okay, angle A is congruent to angle T. Marin, tell me the reason for that. What is that statement? Property of what? Are those equations? Is that an equation symbol? Is that an equal symbol? Transitive property of congruence. Okay, now the question is, so this one, the first one up here was only substitution and not transitive. Okay, the first one was only substitution and not transitive for the equations. The second one was either substitution or transitive for equality. Now the question is this one also substitution? What do we think? Is that one also substitution? Good. Because exactly. Good. So this one is not substitution because substitution is not a property of congruence, right? If you look up here at the properties of congruence, there's reflexive, symmetric, and transitive. There's no substitution when you have congruence. Substitution is only a property of equality. Now, this is kind of like confusing maybe at first, but this is an important distinction because you want to not be missing problems because you're calling things substitution when they're not. Okay, substitution is only a property of equality. So that means this is only transitive. Transitive property of congruence and nothing else. Okay. So, yes, right. So if it's like this, where you've got equal signs and you're wiping out a whole side like that, you could call it either transitive or substitution. But because of the congruence, that one is only transitive. So last thing on these notes, let's jump back up here and see if there's any of those that could have had other answers. So for number two, is it possible to call that substitution? So we called it transitive because we wiped out a whole side of the two equations. Could you consider that to be substitution? Look at number two. Zach, what do you think? Could you call that one substitution? Tell me how. Okay, you could just replace angle 1 with angle 2 and get your conclusion, right? So that one also could be substitution. Transitive or substitution. I think transitive is the better answer personally, but I wouldn't count it wrong if you wrote substitution. Now, generally speaking, when you're doing a proof, you don't have to list more than one reason. I would prefer you only give me one answer because I don't want you to accidentally write something that is wrong and then get counted off because you were overzealous. So if I give you a problem where I'm specifically asking about the distinction, like this kind of thing, then I would want you to be able to tell me, both of them. But here, I just want to make sure you understand. I just want to make sure that you understand that one could be both. Okay, how about Sam?
So if we write it down, like if this is a substitution, then we want to like substitution property of equality to substitution.
No, you need to write substitution property of equality because I want you to get it in your brain that substitution is only for equations. Yeah. And then I want you to, because if you get in the habit of writing congruence and equality, you'll catch yourself sometimes. Like, oh, wait a minute, this thing can't be substitution because it's got congruence in it. Okay, for number 3, that one I said transitive. Could we call that one substitution? Jimmy hasn't talked to me. Miana, tell me what you think about number 3. Do you think you can call that substitution? Yeah. So we can just go ahead and say, I'm trying to make A be equal to WY. So since these are equal, you just replace right there, take out RS and put AB in its place. So that one could also be substitution. So again, if it's a property of, if it's equations and it's transitive, it will also be substitution. But sometimes substitution is not also transitive. So let's look for others down here. Let's see, substitution, number 5. How about number 5? We said that yesterday that was substitution. Could that be transitive? Let's count. Here's thing 1. Is this thing 1 or something new? Okay, talk with me here. That's thing 1. Is this thing 1 or thing 2? Is that the same as the first thing I circled? Okay, so that's thing 2. Is this thing 1, thing 2, or something new? Okay, how about this? Okay, so you've got thing 1, thing 2, thing 3, thing 4. Can that be transitive? No. Okay, transitive, you got to have a whole entire side that matches in the 2 equations. You have to be able to wipe out a whole side of the first one and a whole side of the second one. Okay, this one is substitution. However, it is not transitive. And again, the idea is substitution is more specific. So sometimes substitution is only substitution. Okay, that one is just substitution, not transitive. Do we have any others down there? No. Okay, and if it had congruence, then it would only be transitive for congruence. All right, let's go ahead and check homeworks. So we need to look at number 20 and number 21, correct? Am I right about that? Okay, so number 20 was the one that was called like inductive versus deductive worksheet, and it had some book problems with it. Remind me what inductive is versus deductive. Inductive versus deductive, Sam. Okay, wait, I was with you until you said pattern.
Yeah.
Okay, so inductive is the pattern one, right? Inductive is, here's a few examples, try to infer what's coming next. Deductive is, here's given information and you're going step by step applying logic, rules, postulates, policies, properties to make a valid conclusion. So deductive is the step by step. Inductive is, here's some few examples, try to make a generalization. So inductive was from the beginning of the chapter where you have a few examples. Okay, so like the chair is red in the living room, the chair is red in the dining room. So you assume all the chairs are red. That's inductive. Questions on those? Okay, here's the detachment syllogism. Remember that syllogism is the one that's similar to transitive. So we talked about that back when we did syllogism, but we hadn't talked about transitive, so you may not have, that may not have stuck with you. Syllogism and transitive are similar kinds of patterns. Brooke, you have not submitted homework 21, which is the one that was due today. Okay, questions on those? Mm-hmm. No, you really don't. Law, syllogism, and detachment are more to help you think about the idea of logic. Yeah, it's not really going to be something that you will use as a reason in a proof. Yeah, that's a good question. Okay, any other questions on that group of problems? Okay, here's the book, from the book. I think number 6 was asking you to give a counterexample. I think what they're describing here, they're saying if you have 3 lines that don't make a triangle, then that's your counterexample. 3 coplanar non-parallel lines intersecting at a single point do not make a triangle. I'm going to read you number 17 because I know that it's kind of hard to be checking back and forth. The converse is if an integer is divisible by 2, then it ends with 0. The inverse is if an integer does not end with 0, then it is not divisible by 2. The contrapositive is if an integer is not divisible by 2, then it does not end with 0. And then lastly, it asks you which statements are true, which ones are false. Conditional and contrapositive are true. Remember that those are equivalent, so they're always going to have the same truth value, but they're both true. But the converse and inverse are both false. And then one possible counterexample is the number 4. 4 is divisible by 2, however, it does not end with 0. So any number like 6, 4, 8, any even number that's not a multiple of 10 would not be ending with a 0. And then here's the last ones. Okay, any questions on this assignment before we talk about the newer stuff? Okay, and then here's homework 21 answers. I'll zoom in a little bit more. Now, a few things that might have been new. Number 2, part B, you may not have known that you're allowed to say simplify or combine like terms because I'm not sure that we did that on, we talked about that before. But simplify is, let me say this, that is not addition. Okay, this one is not addition because addition property of equality means you added something on both sides of the equation. That is not what's happening here, right? 80 didn't change other than I accidentally put a space in there. Okay, 80 did not change. What you did is say, okay, 3x and 6x, I'm going to combine those together and call that 9x. And then 3 and 5, I'm going to combine those together and call that 8. So you can say you're simplifying, you can say you're combining like terms. You can also call that substitution. algebra teachers like to call that substitution because they're saying, I know that 3x and 6x is 9x, so I'm taking those out and I'm replacing it with 9x. Okay, so any of those would be okay. It is not addition. But simplify, combined like terms, or substitution, property of equality would be okay for that one. Okay, any questions about 1 through 3? Caroline? Yes, you do not have to list both. Yeah, I would honestly prefer that you only give one answer because, again, sometimes you get overzealous and you put 2 answers and then it's like, oops, one of them was right, but the second one's not. So it's better for you to just put one answer. Okay, here's, I'm not going to start on that one yet. Here's these. If you need to kind of work it out, like I did here, multiply both sides by 5 and think about what's happening, then do that because you don't want to make a silly mistake in your head and then write the wrong thing there, even though you know that it should be 50. So this last one says substitution, property of equality. Could that one be transitive or not? Transitive or not? Could this one be considered transitive or not? So it is substitution. Is it also transitive? Sam? It is not because why? Yeah, correct. So here's thing 1, here's thing 2. This is something new, so that's thing 3, and that's something new, so that's thing 4. You do not have an entire side of the 2 equations that are the same, where you're able to take them out and mush it together. So just side note here, this one is substitution, however, it is not transitive. And again, often the substitution ones look like you just replaced part of a side and not an entire side. So you just replaced one term. Okay, here's odd ones over there. Remember that symmetric is the one that you're switching the sides. Reflexive is the same thing on both sides. Sometimes I think of reflexive like you look at yourself in the mirror, you're seeing yourself, so it's the same on both sides. When you look at yourself in a mirror, what is that called? It's your what? It's your reflection. So this is reflexive, but it's kind of like the idea of reflection. Okay, how about over here? Now, for number 8, you could either have said transitive, and that would be a correct answer, or you could have said substitution, and that would be a correct answer. I think transitive is a better answer because we're wiping out this whole side of the equation. So I think transitive is a better answer, but it is also substitution. So either of those would be okay. All right. But number 12, again, you're just replacing part of the side with what that value is equal to. So that one is only substitution. Questions on any of the ones 5 through 12? Okay. It is really important that you correct these so that you have lots of examples to look at, because at first these can be a little confusing, but the more you practice it correctly, the better you'll get at it. And again, where I wrote or, you could have just one of those and it would be a complete answer. You could say just transitive or just substitution and be fine. And somebody said that the version that I posted, I think it was number 5, that you have congruences there. That's a mistake. You can't have congruences with subtraction. Okay, subtraction is a property of equality, so that's a typo. And I think I corrected it on my P, and I didn't correct it on the document I posted. So scratch that out. It should not be congruent. It should be equality. Questions on that group of problems? How about this proof? You could say definition of complementary or complementary angles. Either of those would be okay. All right, so how about this one? Could number 3 be transitive? No. You're just simply replacing the angles with what their measures are. You are substituting. That is not transitive. Okay. And again, the number 4 is simplifier, combine like terms, or substitution. But you may have gotten a little confused on that because we hadn't talked about that before. Why is this not addition? From here to here, why is that not addition property of equality? Sam? Correct. Addition, multiplication, subtraction, division. The operational ones are something you're doing on both sides of the equation. Here we did not add something on the right side, therefore it cannot be addition. Okay, and then here's the last one. It's important that for number 2, that you have an equation there and not a congruence. Because when you're doing things like substituting and subtracting and all that, they have to be equations. When you're doing operations or substitution, they have to be equations. So while it's true that segment DE is congruent to segment EF, that's not what you should write there because we're doing a substitution and plugging into an equation. Okay, so again, there's kind of subtle things you need to watch out for. And there's a lot of details to kind of keep track here. And then at the end here, I would just call that simplify. If you wanted to call that substitution, you can. It's really not adding like terms because there's no variables there. You can just take a picture of that if you don't want to have to write them down. So here's a few more examples. I want you to take a minute and see if you've got this straight or not. So write all the possible answers for these 3 problems. Okay, and so make sure you put property of equality or property of congruence. And I want all the possible answers. So if it's only substitution, then you write substitution property of equality. If it's both, then you write both of them, okay? Make sure you pay attention to property of equality and property of congruence. Zach, what do you think about number 1? Okay, tell me how it's substitution. Okay, so we're taking the X out and putting 10 in its place and getting 18. All right, now, he said only substitution. Somebody tell me why it is or is not transitive. Okay.
Because there are 4 distinct terms there. We have x plus 8 is 1, y is 2, it's the normal x is 3, and 10 is 4.
Right. Okay, so do not have any full-sided equation there that matches up, so this one is not transitive. Okay, how about number 2? Allison. Tell me why. Good. So it is transitive and it's congruence. Remember, there's reflexive, symmetric, and transitive properties of congruence. There's no other property that has congruence. So if we try to do the kind of canceling out thing, we've got PQ is the same in both. We can take them out and make those congruent to each other. It is not substitution, which is what Allison just said. Not substitution because it's congruence. Okay, if it's got congruence in it, it can never be substitution. There is no substitution property for congruence. Okay, and then for number 3, Tiana. Okay, tell me why it's transitive. So what are you canceling? What are you wiping out? So these two match up, so we can say take those out, and those will be equal to each other. Is that property of equality or congruence? Okay, now tell me how it's substitution. Okay, so kind of what type of replacement thing are you doing? Yeah, so basically you can take that and plug it in over here and make angle 2 equal to that. Good, okay.